Welcome to Logic First. In this video, let's learn about topological sort. Let's understand this by taking an example. Say the nodes here are the programs and the graph represents the build dependencies of the programs. I now want to build this program I. But for that, first H has to be built. Of course, there are other dependencies as well. But for H to be built, D has to be built, and for D to be built, E has to be built. We now need an order in which these programs can be built without running into any dependency issues. Let's now try to find out such an order. A can be taken as the first node in the order because it doesn't seem to have any dependency at all. There is no incoming edge for A. Can we take D as the next node? We cannot, right? Because D doesn't depend just on A. It also depends on the program E. So without building E, D cannot be built. We can probably go with B because B does not have any dependency. And then we can take C as the next in the order. Next we can take either E or F. Let's take E first and then probably D and then F. Next H can be taken and then G and then finally I. So if we go by this order, we will not have any issues while building the programs because all the dependencies will be resolved. So such an order is known as the topological sorting or topological order. Note that A, B, C, all these three nodes have no dependency at all. So any of these can be taken as the first node. Similarly, after A, B and C, it can be E or F. So there are many different possibilities for this graph. So topological order in general is not unique. This order right here is just one of the several possibilities for this graph. Topological sorting is possible only in directed graphs because in undirected graphs, topological sorting is not necessary at all because there is not going to be any dependencies like in directed graphs. If I draw the edges for these nodes like in the graph, we can see that all the arrows are pointing towards the right. If we realign the graph for this order, all the arrows should be pointing towards the right side always. If you take this graph, can you write a topological order for this? Where will you start? You cannot start with A because it is dependent on C. C is dependent on B. B is dependent on A. This is a cyclic graph. Similarly, if you consider this one, again you cannot say which one comes first at all. It is like a chicken and egg question which cannot be answered. So it is impossible to find a topological order for cyclic graphs. Topological sorting can only be done if your graph does not contain any cycle. Topological sorting for directed acyclic graph is a linear ordering of the vertices such that for every directed edge UV, U always comes before V in the ordering. If you take any directed edge of the graph and name it as U and V, V being on the side of the arrowhead, U should always come before V in the ordering. If you check for each and every directed edge of the graph, this should be the case. Such an ordering is known as topological ordering. Topological sorting is used to solve build dependencies, course scheduling, symbol dependencies in linker, sorting logic gates during logic synthesis, data serialization, and almost in any problem where graph dependencies occur. Topological sorting can be found by making some modifications to depth first search and also using Kahn's algorithm. Thank you.